Welcome back to another video tutorial for Introduction to Solid Modeling. In this video we're going to talk about assemblies, what they are, how to create them, and the general mechanics to include parts in them, and we're going to discuss what mates are and what their function is in assemblies. Okay, so I'm sure everyone who's watching this video has seen one of these before, probably when you were growing up. It's one of these ring toys. I'm going to show you how I created this assembly. You can see in the tree over here we have all of these parts, and these are just parts that I've created similar to how you've been learning to do all semester. So if I want to create a new assembly, I just use the normal File New mechanics, and I'm going to select Assembly this time, and we start with a new assembly. This looks exactly the same as it does when you go to create a part. The difference is we're not creating parts inside of the assembly, we're inserting components that we've already created. So for example, I will choose to insert a component and I will choose base. I can just hit open, and you see as I move my mouse around, I could click anywhere in the design space and it would just place the base where I'm clicking. Or I can hit the check mark and it's going to align all of the planes from this part with the default planes in the assembly. That is advantageous, and I recommend doing that with at least one part. You'll also see that it has this little F inside the parentheses right here. That means that this is fixed. I cannot drag it. If I click on the part and try to drag, it'll give me that message that says the component is fixed. It cannot be moved. Okay, now you can still rotate these views the same way you would inside a part, and I'll give you some tips and tricks for how to rotate different parts when they're in, and you'll understand a little bit more about what I'm talking about when you actually do it. But for now, let's go ahead and insert the biggest ring. So in this instance, I'm just going to click and place the ring right where I click. So I mentioned earlier that there are some tricks to manipulating the parts inside of an assembly and also just the view of the assembly. If I hold the scroll wheel on my mouse and drag, it rotates the entire model just how it does in parts. If I want to move an individual component that is not fixed or constrained in any direction, I can left click on a surface and drag, and that will move the part, it will translate it. But if I want to rotate the part, I can right click on the same surface, and when I drag, it will rotate the part. Okay, so you can see that I have two parts inside this assembly. We have the base and we have this extra large ring. In order to constrain this ring in the correct position, or place it in the correct position and fully define that position, I can use what are called mates, and you can see that up here in the top left with the little paper clip. So if I click on that, it's going to open this window on the left where a box that has mate selections will show up, and I'm going to select the bottom of this ring and the top of the base right here. And when I do that, you'll see it's already trying to add an automatic coincident mate, and that means the same thing it meant in parts when we were adding sketch relations. That is just making sure that those two surfaces are in contact with one another. And that's what I want to do in this case, so I can hit the check mark. Now I have it constrained in one direction. I have it constrained in the Z direction. It is up against the top of this base, but I need to constrain it in the X direction and the Y direction. So you've all played with one of these. You know that the ring goes over the little peg in the middle. So if I select that surface and then I select the surface of the peg, Solidworks is going to recognize that those are two cylindrical or circular surfaces, and it's going to automatically try to add the concentric mate, which again is the same as the sketch relation, essentially it just puts the center of the two circles on top of each other or makes them coincident, which is what I want in this case. You'll notice there's this little checkbox down here called lock rotation. I'm going to go ahead and check that, and when I hit the check mark, you'll notice that now I can no longer move this red ring. It is fully constrained, fully defined. I've constrained it in the Z by making it coincident with the base, and I've constrained it in the X and the Y, making it concentric with the peg. And the reason that I fixed rotation is because if I hadn't done that, this would still be undefined, and that I could still rotate this circle or this ring around the peg. But now you can see that little dash inside the parentheses is gone, and this ring is fully defined. And I'm going to go ahead and insert a couple more of these parts and show you some helpful tricks. So I showed you one way to insert components by clicking up here and browsing. You can also just drag the part from File Explorer straight into the model. And now I can do the same thing. I'm going to click on this surface and rotate it just so that it's kind of in the correct orientation. And here's another little trick. If I hold down Control and select another surface and then release Control, we have all of these mate options pop up. And what did we do last time? We wanted the coincident mate. So if I click that, it adds a coincident mate between those two faces. And I can do the same thing with the inner part of the ring and this peg. So you can see now I don't have the lock rotation on this coincident mate. And it's hard to tell, but this ring is spinning. And I can tell that it's not fully defined based on this dash inside of the parentheses. And what I can do to fix that is if I click the drop down on the extra large ring and then click the drop down under the mates folder, I can edit this mate by right clicking on it and editing it. I can simply click the checkbox that says lock rotation, and when I hit the check mark, now it is fully defined again. You'll also be able to tell that the entire assembly is fully defined based on the status down here. It'll say fully defined or underdefined, or potentially even overdefined if you have a mate that is either not necessary or trying to do something that is not possible based on your current constraints. And I'll show you an example of that. We've already talked about how this orange ring is fully defined, and if for whatever reason I tried to make the top of this ring coincident with this base, it's going to throw up an error that says essentially this is impossible. Do you want to break, or do you want to add this mate and break others? And that's just one way to inform you that, oh, you are already constraining that part in that direction, and that's not really required. So now I'm going to take some time to go over, I guess, the most popular mates, and you'll be able to find those under the standard tab inside the mate. You'll have coincident, which we've already used. Parallel will just make two surfaces parallel to each other. Perpendicular does the same in terms of its function, but obviously it's perpendicular instead of parallel. Tangent is exactly what the picture shows, making a round surface basically coincident with a flat surface. Concentric is locking two origins of circles together essentially, and a lock will simply just fix the two components relative to each other in that location. There's distance, and that sets a distance between two faces or planes, and angle does the same thing. feel free to go ahead and explore some of these. Obviously they won't all be applicable based on the stuff you're assigned, but if you ever are just messing around in assemblies, feel free to play around with some of these. I think that'll just about wrap up what we need to cover in order to get you started with assemblies. Thanks.